5C of the beginning bioinformatics section. Start sharing my screen. So we'll be picking up with P20. The last thing that we went over in the in-person lectures, which are still recorded and available, was combining for loops with file objects. And then that got us through Rosalind problem number 4, working with files. That's the one where you have to print only the even numbered lines, I think, in the Bravely Bold Sir Robin poem or song. I think it's from Monty Python, Quest for the Holy Grail. But in any case, we're going to start with P20, which is introducing a really convenient aspect of Python that lets us loop over strings. So up to now, we saw in some previous exercises, 15 and 16, how you could use for loops to iterate across lists. So where the thing that we want to iterate over was already broken up into items in a list, or we did it where we could specify a range and then do the for loop a certain number of times based on the range that we set. But a cool thing, and one of the things that makes Python really useful for, say, DNA sequence analysis, is that it will loop across a string just like it was a list. So this little example I gave, if the word is hello, and we do this for loop for letter in word and then do print letter, it's going to get each element in that string and print it one at a time, just as though it was a list, right? So that return would be HELLO. Okay. So that again, super useful for the way we often want to analyze DNA or RNA sequences. I'm not sure if that's Rosalind number 6. We'll get there in a minute, but right now we're gonna work on problem number 5. This I think I might have. Oh no, number 6 is where we're going to go across a string and count up nucleotides. So we will want to loop over that string. But in number 5, we have a different kind of string, right? So we have a sentence that is, like all sentences, broken up by spaces. Okay, and so we want to split this sentence up by single spaces, and the command here that we're adding to our vocabulary is the split command. So that's why this exercise is for word in line.split. Okay, and in this case, line is the name of a string. Okay, so let's do task 20.1, where we print each word in Rosalind number 5 sample data set on a separate line. So first we need to make a practice data set. We tried list and we tried dicts. We tried Zen. So just like we did in class last Thursday, go ahead, let's get Spider open. So there's my practice file. I'm going to do file, save as, and in this case, I'm going to save it in my download folder. It doesn't really matter as long as you have access to it and you know how to specify the path in your code. Call it practice5.txt. So now I need to write some code that will print each word in that sentence one line at a time. Okay. So file. That's the practice. Okay. So my code, just so I oops, users. My tab complete was not working, so I knew that I must be getting something wrong with the path. There we go. Cool thing in Spider. So I hit tab complete in Spider, and these are all the things that match it right now. So there's practice. That's my practice file that I need to use. And I'm opening it in read mode. Whoops. As data. Okay. And then I need to get that line, right? So remember the objective here is to print each word in that line. So data equal line equals data.read. Remember, read is going to read the whole file in one piece, but in this case, the file is just one line, so that's just that, you know, it would be the same as doing read line in this case because the file is only one line. And then we're going to do for word in, right? This is exactly from the tutorial text, right? The hint for word in line split, okay? And right here, I've given a little background on split. Okay, so the default for split is to split on white space. You can put other delimiters in there, right? If you wanted to split it on underscore or something like that. It's kind of the same thing. We had similar delimiter specification when we did, you know, the cut sort unique back in the Unix section. So forward inline dot split. Oh, can't type. There we go. Remember for loop, you just end that with a colon. And then print word. Okay. So in my practice data, let me open that. Well, it should look just like this, right? It should. This is my practice data. And so if it splits on the spaces, what we're expecting here is that this code is going to print we, and then next time through the loop, it should print tried, and then list, and so on, because it's splitting based on the spaces. So let's run it. And that's what we got. No surprises, okay? So if you delete the box, you should get something like this code. I didn't put the comments in my code here, but same thing. Okay, so that's splitting a sentence or any input based on any delimiter, right? You could use this split command to read anything in and then split whatever you're reading in based on whatever delimiter you put in the brackets on split. Okay. So next one, P21. This is a really important one to learn, the dictionary data structure. A dictionary is another type of variable, just like a list. In fact, it has a lot of similarities to a list, but where a list is indexed by the number that represents the position in the list, so it's ordered, a dictionary is not ordered. And we don't call it an index, we call it a key. So dictionaries are made up of key value pairs. So here in this example, I've given a dictionary that has 4 elements in it, and the key for the word hello is H. And so to reference the word hello, we have to tell it, dictionary position H. Okay. Whereas the data structure of a list would be the list position 0. Okay. The cool thing about dictionaries, right, is that, well, one, they're not ordered. That's not a cool thing. It's just because there's no necessary relationship among the keys. There's no certain order that they're occurring. Like, this is not necessarily sort of first and last. They're just all items in the dictionary. Okay. So there's a lot to unpack here. Just in terms of the syntax, Python will know it's a dictionary because instead of using brackets, we're going to use curly braces, right? We used brackets to specify a list. To specify a dictionary, we're going to use curly braces. Okay. And then when we want to assign a value, we're going to use this key : value notation. So, and we're going to make some here in the code below. Now, this thing I've mentioned lots of times, important to start or do your best to try to think like the computer. When you tell Python print my dictionary and then the brackets here, right? The brackets are just like when we were trying to pull a specific item out of a list. We would have the integer for the index in the list, right? And if we were talking about the list and we were trying to call the position, we would put a 3 in brackets, right? So when we're trying to call the position or the value in the dictionary, we have to put the key in the brackets. So in this case, when we say print my dictionary and then we put CD in the brackets, Python returns Charles Darwin in this case, right? Because when you tell it this position, Python sees Charles Darwin. Okay. So let's go ahead and create this little script just so we can see how dictionaries work. I'm going to save a little bit of time here. You can pause, but I've got these already typed out. So here I've created a dictionary with the variable name sequences. So sequences is the name of the dictionary in this case. And then I've said equal, and I've started the dictionary with open curly braces. And then you'll often see in code dictionaries that are hard coded, where the contents of the dictionary are actually specified in the program. They'll do it in this sort of column format where you open the dictionary and then each line has the key, in this case H. neanderthalensis, colon, and then the value, which is this sequence. Okay, and then I have to do a comma, just like we did for list notation. Okay, the comma specifies the items, or distinguishes the items in the list. So we put a comma there, and then on the next line we have H. sapiens as the key, and then a colon, and then the value. Okay, so hopefully you recognize similarities between dictionaries and lists, because I think that will help you at least reduce the sort of barrier to using dictionaries. If we were making sequences into a list, we could specify the sequences here, the ACGTs, as the items in the list, and we wouldn't have to put the values. But in this case, we want to associate the name of the species with the sequence for that species. So then if we wanted to see what was in our dictionary, we do print sequences. Okay. And then let's run it and see what happens. Okay. So this was our output. And remember, just like when we say print and then the name of a list, we get the weird notation with the bracket and then the quotation marks that has the item in the list. Same deal here. When we say print the dictionary, we're literally getting the whole dictionary. Python is printing the curly braces. It's printing basically just what we gave it. Okay, the keys and the values. Okay. So the next section is manipulating them and then printing them in a little bit more meaningful way, or at least a better formatted way. So let's first add one item to our dictionary. We're going to add chimpanzee sequence. So to add one thing, sequence is the name of our dictionary, and then in brackets, we're specifying P troglodyte. Now, when Python looks at this, it's going to look in the sequences dictionary for a key that matches that. There is no key that matches that, so it's just going to add this as a new key, and it's going to give it this value. So I'm going to move the print statement down here. And now see how it added P troglodytes as the new item in our dictionary. I'm going to undo that just to, we don't need to have that print statement anymore. The next thing, just another way, so this, the way I added chimpanzee only works for adding a single item, right? Because we just gave it one key right there. If we want to do multiple items, there's a command to update the dictionary. So we can do something like this. Okay. So sequence.update. This is a command we, for lists, we used append and insert. Here, update is a command that is useful for dictionaries because remember, dictionaries are not ordered. We're not necessarily adding it to the beginning or the end of the dictionary. We're just adding two new keys, gorilla and Homo erectus, okay, along with their sequences. So just to show you example, now if we want to print a specific thing from the specific sequence from our dictionary, again, back to thinking like a computer, if we want to print the sequence for modern human, we're going to say the name of the dictionary, and then in brackets, what's the key for that sequence? The key is the species name. So this should print that sequence. So let's play it. This is the sequence that we got, and indeed that is the sequence for Homo sapiens. Now, what if we want to print the whole dictionary? In that case, we need to use another function that Python gives us for dealing with dictionaries, and that is the items function. So we need to specify two values, and often you see it as key value, right? So those are going to be in our for loop. We're actually going to have two variables on this loop at the same time. You don't often see this outside the context of a dictionary. Whoops, that's not what I want. Right, so this essentially is telling Python, loop through this dictionary and get each item one at a time in a key value combination. So it's going to grab the key and the values for that key at the same time as it loops through. So in this example, I'm basically providing instructions like, let's print this out, this dictionary out in FASTA format. So, right, the FASTA header starts with the greater than sign, and then we're going to print the key because that's the species name. So that'll go in the header, and then we need a new line. Whoops, should put quotes there. So that's going to print the header, and then the species name, and then a new line, and then let's add the value, right? Because the value in our dictionary is the sequence. Okay, so this should loop through, print greater than sign, the name of the species, and then a new line, and then the sequence on a new line. So it seems like that should look like a FASTA file. And I got an error. Oh, because here I have a typo in the name of my dictionary, right? It said name error, name sequence is not defined. Okay, and that was on line 16. So now, ta-da! Okay, so we printed this dictionary where we specified species and sequence as a FASTA file. So if you can do that, and you've done the for loop number 20, you should be able to come up with a way to finish Rosalind problem number 5. So Rosalind number 5 says, given a string with length up to 10,000 letters, return the number of occurrences of each word where the words are separated by spaces. So basically, it could give you a very long sentence, and it wants you to count the number of words in that, count the number of times each word appears in that sentence. Okay, so we've already shown in, I think it was number 20, how to do each word one at a time. And so the reason to add dictionaries is that we need to somehow hold the word as a key and then count how many times it happens. So I've given you some pseudocode here, right? So I'll go ahead and walk through at least part of this. Right, so opening the data file is going to be with open. Okay. I'll just say path file name. And I think in this case it's Rosalind underscore any6.txt. Right, so the reason I say that, right, so when you do download dataset, yeah, so Rosalind underscore any6. Mine has a 1 because I downloaded it multiple times today, but right. So that's the name of the file, but the path here is going to be unique to your system. So you'll have to type in whatever that path is. Yeah, so then what are we going to do with it as data? And this is just like our practice data. In fact, you know, we could have opened that practice data file back, or the practice program, but you know, how did we start it? Like this. And again, this is just like, oh, I have kite turned on. Because this is a single line, we can do it just like we did before. So we read the file, we've got it as one long string. How do we initiate an empty dictionary? Because this is what's going to hold our keys. We're going to make each word in this dictionary a key. So we need an empty dictionary. Let's just call it dictionary. Whoops. So that's how you initiate an empty dictionary. And then we, number 4 here, loop over the file and get the words one at a time. Okay. So remember our code, and you can go back to this, you know, this was P20. For word in line split, we did print word. Okay. So maybe I'm getting ahead of myself a little bit here. Let's make sure we're okay to this point. So we can do, on my computer, this is going to be user, oops, users, come on. Users slash down there. Okay, and so then I should be able to do print line. I'm going to pretend these lines don't exist yet. Just comment them out. And the reason I backed up here is that I want to show you, as you're learning to code, a lot of times it's good to make sure things are working one step at a time. Once you get more and more confident, you'll be fine adding longer and longer sections of code before you test. But for now, you know, if you're not too comfortable with any of the commands, make sure that things are going the way you expect them to go, one section at a time, or one item in the pseudocode at a time. So here we're just going to be able to read in the file and then print it. Oh, forgot to put my parentheses on my line, on my print command. Okay, so I don't think that's the one. Oh, I know why. That happened to me because I messed with this earlier today, so it was reading the wrong file. So Rosalind ini 6. Now try it. There we go. Okay, so it actually gave me a pretty long line, and so one way to see this is not actually multiple lines is that as I resize the window, see how it's. If I could make this window wide enough, you would see that this is literally all one line. And that's important because of the way we read the file in, right? So we use the read command, which reads it all as one chunk. And Rosalind told us this was just going to be a single string. Okay, so it was read in as a single string. Okay, so reading it in and printing the line, that worked fine. Okay, so we can take that out. We don't need to print the line every time. So then we come back, we specified our empty dictionary. We have a for loop that we expect to get each word in the line split by a space. So let's make sure this is working right. Okay, this was our same code for P20, exercise 20. Okay, and you can see it took that really long string and printed it out one word at a time. So great. Now all we have to do is write a little section in this loop. And rather than print it, we need to count. So there's multiple ways we could do this, but with the code that we know so far, we can check to see if this word is in our dictionary already. And if it is, then we're going to add 1 to the count. And if it's not, we're going to make the count 1. All right, so we say if word in dictionary, whoops, if word, I can spell, if it's in the dictionary, what do we want to do? So we want to make dictionary word equal whoops. So what this is saying is, right, think about what does Rosalind see here? It doesn't see the word, it sees the, because remember, word is a key in the dictionary. So let's just say, go back to the beginning, right? So the first time through the loop, the value of word is going to be when. So if when is in the dictionary, so if this key is in the dictionary, then whatever value it currently has, and right now we have, right, we're only on the condition that it's already in the dictionary. So maybe we should skip down and say, well, what if it's not in the dictionary? So hopefully, so if it is in the dictionary, then we're going to add 1 to the value. If it's not in the dictionary, then we're going to make the value equal to 1. Okay, so it's only going to do this if it finds word in the dictionary. So first time through, finds when. This evaluates to false, so it goes to the else, and it makes the value of when equal to 1. So the next time it sees a when, then this will be true, and the 1, right? So that dictionary of when with key when will be equal to 1, and it will say turn that 1 and add 1. Now, I'm going to change this to the shorthand that hopefully you will recognize. The spaces don't matter. I'm just trying to make it a little more legible. Right, so what I changed this to is exactly the same. Remember, we've done this all last week with this shorthand for when you have a variable and you want to add one to it, you can do plus equals. So that loop should count words for us. Every time it sees a word, if it's in the dictionary, it'll add 1 to the count, and then if it's not in the dictionary, it'll make the count equal to 1, the value equal to 1. Once it's all done doing that, we need to use our loop, like we from the last exercise. Right, the for key value in. I have extra. I'm curious. I don't know why. I think that might have been just a typo. Let's see if it works. Sure does. If you get an error, back up and put print statements in. So we've already seen that this works, the for line dot split for word in line. If you're not getting correct counts, you can put, right, if you put print statements in here. Actually, right, so what I expect now, every time this is true, every time there's a word in the dictionary, this is going to print the word and the dictionary value of that word. So let's take out our former stuff. And this, again, I'm just showing an example of if you're having trouble, this should show us as it counts. So every time it sees a word, it's going to add 1 here. Oh. I wanted it to print the word and then a colon in the dictionary, but I forgot to make that colon into a string because it's just a character that I want printed between the key and the value. Okay, so this is going to be really long or longer because, right, so when it saw of the second time, right, why didn't it print of colon 1? Because when it got a 1, the first time it saw it was because it was running the else part. Then it only ran this part the second time it saw the word of. And then you can see the third time it saw of, it added 1, there's 4, 5, okay? So all is well. Okay, so you should be able to get Rosalind number 5, the dictionary problem there. Number 23 is using the count command. Count is a nice function and it works on any iteratable object. What do we mean by that? List, dictionary, and now we know string. So, right, because we just iterated over a string that we used the split command on. We used that to iterate and count the words. In Rosalind 6, we're going to get this string. So let's turn this into our practice file. You can do this in Spider. So I just created a practice.txt file. Actually, I can show it over here. That's not it. Oh, I know why. It's because I decided to put them in my downloads folder rather than move them, because since Rosalind downloads things automatically to my downloads folder, it's just easier for me to keep the practice in the same spot. A lot of stuff in my downloads folder. There. Okay, so that's what's in my practice now. So we've done make a practice file with the example data set. We need to open it, read it into a string, and then do the count on ACs, Gs, and Ts. With open. Actually, I'm going to be lazy and not type it all out. So that opens the file and reads it in just like we've done on the last couple of examples and exercises. So we've got our DNA read in as a string. Now, one way would be to create a variable for each nucleotide. And the variable name DNA, that's our string. And we can just say, count the A's. Okay, so count makes it super easy to count stuff. That's literally all there is to it. And then we just print A, C, G, T, right? Because we've named our variables A, C, G, and T. This print statement is going to print the count for all 4 of those if we got it right. Right? Okay, so look at the Rosalind problem and ding, 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 ding. We got it right. 20, 12, 17, 21. Now, obviously, I went with the order here. That's important. So ACGT is the order that it wants it in. I could have done all of this inside the print statement. It's one of the cool advantages here. I could do it like this. And there is no difference other than less lines of code. Right, so I'm going to put comments so that Python doesn't read those. So now I've gotten rid of that stuff, and instead of first defining each one as a variable, I'm just doing all the work right inside the print statement. And it does exactly the same thing. No benefit to doing one way or the other. Sometimes, you know, doing it this way is more legible. Like the person who comes along later may be able to read this and, you know, modify the code to do something a little different. This format might be easier than if everything's specified in the print statement. But this way is, in terms of coding, a little more efficient just because there's less typing. It's all basically you've done the whole thing in one line of code. So the task that will allow you to finish Rosalind 6. Okay, you just have to, instead of running it on the practice data, download the real data and run it. The challenge here, and there's no Rosalind problem for this, is can you modify the dictionary problem? So go back here and modify that so that it uses the count command. Right? So you can imagine maybe instead of having to ask if it's in the dictionary, add one to the value. We could just say if it's not in the dictionary, put it in the dictionary and count how many times it happens. Because that way, every time Python sees a word that's already in the dictionary, it doesn't have to do anything. You can imagine that would be a lot faster than the way we did it, where it had to process a word every time. Because even if the word was in the dictionary, it had to add one. It had to do something with it. Whereas if we use the count command, it only has to treat a word every time. So because as soon as it recognizes, hey, that's already in the dictionary, it can go on and get the next word. It doesn't have to do anything. Okay. Show, for example. So our original code to solve what is it? Rosalind number 5 looks something like this. Okay. But we could get rid of all this stuff and just go, actually, let's, yeah, get rid of that. Ah, come on. Sorry, keyboard's not working right. We could just say if word not in dictionary. Dictionary word. Whoops. Equals. What does it equal? Trying to. Right, our variable is line. So we need it to go into the line and count word. Right. So, right, the thing that took me a second is think about the command. I should have closed it already, but we had DNA.count and then the letter A. Okay, but in this case, it's going to change every time. So our variable that we need to count through, instead of being the DNA sequence, it's the line of data. So in that line, we need to count the current word. And it's only going to do this if the word is not already in the dictionary. I got error here. This happens when you copy paste sometimes. There. I'm not sure what was going on there, but I had an indentation problem. But it worked. The code itself was okay. That's when you copy paste, that happens sometimes. So an alternative way to solve problem 5, at least one alternative way, using the count function. All right, that's it for section 5, part 5. Just one more set of Rosalind problems. So if we go look, that should get you through number 6, counting DNA nucleotides. And then in the next section, beginning Bioinformatics part 6, we'll learn to import the BioPython package to work on 7, 8, and 9. All right, that's it for this section.